Hello students, in the last class we discussed about the chemical properties of the halogens. In this class we can study about the compounds of compounds of the halogens. In our syllabus there are three important compounds. One is the chlorine, dichlorine, the second one is HCl, third one is an interhalogen compound. These are the some important compounds of the halogen. First you study about the chlorine, dichlorine. First you consider preparation of the dichlorine. First method is dichlorine is obtained by heating MnO2, manganese dioxide are commonly called pyrolusite, manganese dioxide also called pyrolusite. By heating MnO2 with concentrated HCl, we get dichlorine, Cl2. Other byproducts are MnCl2 and H2O. These are the important byproducts. Manganese dichloride, MnCl2. You have to balance this reaction. MnO2 plus 4HCl gives 2H2O. This is about the preparation. First method, by heating pyrolusite MnO2 with concentrated HCl, dichlorine is formed. Then second method is, instead of concentrated HCl, same MnO2, manganese dioxide, is heated with sodium chloride, common salt, sodium chloride, in the presence of concentrated H2SO4. Again we get dichlorine, Cl2, dichlorine gas, Cl2, MnCl2, then NaHSO4, liberating water. This is the second method. You have to balance this reaction by using 4 NaCl, 4 H2SO4, 4 NaHSO4, 4 MnCl2 and 2 H2O. You must ensure you have to balance the all inorganic reactions. Without balancing, you will not get the marks. Compulsorily, you have to balance. This is the second method. First method is MnO2 concentrated HCl. Second method is MnO2 common salt NaCl concentrated H2SO4. Then third method is by heating by the action of permanganate, potassium permanganate with HCl. By treating potassium permanganate with HCl, maybe either dilute or concentrated HCl. KMnO4, you treated with HCl. In the laboratory, we are using chlorine water. To prepare that chlorine water, we are generally using this method only. Potassium to the permanganate crystals, we can add that HCl, then you can collect the chlorine gas collected in the water, chlorine. Then in addition to that one, again you get MnCl2, then KCl and H2O. This is the third method, that is 2 KMnO4, 16 HCl is required, 5 Cl2 get evolved, 5 Cl2, then 2 KCl, 2 MnCl2 and 8 H2O. This is for the balancing the reaction. This is the third step. Then fourth method is by the electrolysis of by the electrolysis of brine solution. Brine solution. Brine solution meaning is saturated solution. Saturated nearly 8 to 10%. Saturated solution of sodium chloride. Saturated solution of sodium chloride. That is 8 to 10% of sodium chloride in water, commonly called as the brine solution. To the brine solution, if you pass the electric current, this is used for the manufacture of caustic soda, that is NaOH, by using the Nelson's process. In first year syllabus, we are discussed about the caustic soda manufacture by using Nelson's process. In that one, we are using electrolysis of the brine solution. During that Nelson's process, we get two important byproducts. The important byproducts are, one is the chlorine. Chlorine is evolved at the anode and hydrogen is evolved at the cathode. For this one, reactions they are not mentioned. In first year already you have written the reactions. Hence here only you have to write the theoretical words. This is about the preparation of the dichlorine. That is electrolysis of the brine solution. Electrolysis of brine solution, we get two important byproducts. Chlorine is obtained at the anode and hydrogen is obtained at the cathode. This is generally used for the manufacture of caustic soda. Caustic soda means NaOH by using Nelson's process. Then most important method is the Deacon's process. Deacon's process. This is very important one. Explain Deacon's process for the manufacture of the dichlorine. They can ask like this. In the Deacon's process, we get the dichlorine is obtained by the oxidation of HCl. Oxidation of HCl by using atmospheric oxygen. In the presence of cupric chloride as catalyst. At 723 Kelvin. This is the principle. The principle used in the Deacon's process is oxidation of the HCl by using atmospheric oxygen in the presence of cupric chloride, CuCl2, cupric chloride as the catalyst at 723 Kelvin. We have to write the reaction. HCl, atmospheric oxygen, O2, on arrow mark you mention CuCl2 at 723 Kelvin. Then the product formed are the chlorine. Dichlorine is obtained, liberating H2O. Then you have to balance the reaction. That is 4HCl, 2Cl2, 2H2O. This is very most important one. They can ask either Deacon's process or by treating MnO2 with the concentrated HCl. Explain the preparation of dichlorine from the pyrolusite. That is, pyrolusite means MnO2, manganese dioxide, treated with concentrated HCl. Dichlorine is obtained. This is about the preparation. You must practice these reactions. You have to practice, note down as it is. You practice the reactions. They can also use it for the competitive exams also. And 1 mark for completing the equations. This is very most important one. In that physical properties, that dichlorine, it is a colorless gas. It is an yellow gas, not colorless. It is an yellow gas. With pungent odor. Then it can be liquefied. Into greenish yellow. It can be liquefied. If you collect underwater, that turns into greenish yellow liquid. It is soluble in water. These are some of the physical properties. Chlorine is an yellow gas with pungent and suffocating odor. pungent odor, pungent smell. It can be liquefied into greenish yellow liquid and soluble in water. Next, we study about the chemical properties. In the chemical properties, chlorine reacts with most of the metals and non-metals. It reacts with both metals and non-metals to form the corresponding chlorides. For example, it reacts with sodium, then form the sodium chloride. These are all used for the completing the equations only. 2NaCl. They will give the reactants. You have to write the products only. Then Al plus Cl2. Then AlCl3, aluminum chloride. To balance this one, 2Al, 3Cl2, 2AlCl3. Then iron, Fe plus Cl2. FeCl3, then 2Fe, 3Cl2, 2FeCl3. These are the examples for the metals. For non-metals, they are mentioned phosphorus, P4 plus Cl2, then it forms PCl3 or even PCl5 depending on the chlorine number. If they mention 6Cl2, PCl3, 10Cl2, you have to mention the PCl5. Already you are studied in the 15th group element compounds of the phosphorus. One has PCl3 and PCl5. If they mention excess of dichlorine, you have to write the PCl5. If they not mention, that is they given that 6Cl2, you have to write the PCl3. Then sulfur, Site plus Cl2. Then sulfur monochloride, S2Cl2. This is called sulfur monochloride, 4Cl2, 4S2Cl2. This is a reaction with metals and the non-metal. Then second one is the very most important, reaction with the ammonia. This is very important even for competitive exam also, reaction with ammonia. There are two cases. That is, first case is chlorine reacts with excess of ammonia. They given ammonia is in excess. Chlorine reacts with excess of ammonia. Then the product formed is the ammonium chloride, and nitrogen gas is evolved. This is important. If they consider chlorine reacts with excess of ammonia is in excess, then the products formed are ammonium chloride and nitrogen. Then you have to balance 3Cl2 and 8NH3, then 6NH4Cl and N2. This is the first case. Then second case is chlorine, excess of the chlorine. Chlorine is in excess. Excess of chlorine reacts with ammonia. Then an explosive called nitrogen trichloride. It is generally unstable. It is used as an explosive. Then forming the HCl. This is very most important one. These two reactions, even they are taken in the competitive exams also. Here 3Cl2, then NCl3 plus 3HCl. If they mention ammonia in excess, the product formed is ammonium chloride and nitrogen. Chlorine is in excess, then the product formed is nitrogen trichloride. Nitrogen trichloride is used as an explosive. Even in Karnataka city, they considered this one an explosive formed when ammonia reacts with excess of chlorine. The product is, and they can ask like that. Then that explosive formed is an nitrogen trichloride. Then next one is reaction with hydrogen. This chlorine has greater affinity for the hydrogen. Hence it reacts with compounds containing hydrogen. Forms the HCl. Chlorine has greater affinity towards the hydrogen to form the HCl. The product formed is the HCl. That chlorine directly reacts with the hydrogen or compounds containing hydrogen, then the product formed is an HCl. For example, H2 plus Cl2, H2 plus Cl2, then the product is HCl only. This has chlorine has greater affinity towards the hydrogen, or they mention the compound containing hydrogen like H2S, then reacts with chlorine. Again, you have to mention the product as an HCl. One of the product as an HCl and another one as the sulfur. Sulfur is formed. Then to balance that one, 2HCl plus sulfur, or they considered an hydrocarbon like C10H16. C10H16 reacts with an 8 chlorine, 8 moles of the chlorine. Then the product formed is the HCl. Here also chlorine reacts with hydrocarbon, forms HCl, liberating carbon. Here carbon is formed, that is 16 moles of the HCl and 10 moles of the carbon is formed. This is the reaction with the hydrogen and its compounds containing hydrogen. Either directly reacts with hydrogen or compounds containing hydrogen, the main product formed is an HCl. If chlorine reacts with H2, HCl is formed. Chlorine reacts with H2S, then HCl and sulfur is formed. With hydrocarbon like C10H16, any hydrocarbon in our syllabus, they mention only C10H16. You take any hydrocarbon reacts with chlorine, the product formed is an HCl and carbon. Then in the next class, you can study about the reaction with alkalis and oxidizing property. Very most important. One reaction with alkalis is very most important. Note down this one and practice the chemical reaction. These are all important for completing the equations. In the next class, you can study about the reaction with alkalis.